So in that last class, we have discussed about what is magnetic disk. Okay, one example for magnetic disk is our hard disk. Okay, we started with one important key term called the platter. Okay, structure like one CD structure I have shown in the diagram. Okay, like that we are having more number of CDs arranged in that order, which forms a hard disk. Okay, then one spindle in the middle of the platter, then one arm assembly that connects all the platters together, and each the arm assembly will have read and write head for each and every platter. Okay, for each platter we will have one read and write head that is attached to arm assembly. Okay, then each platter is divided into tracks, and each track is divided into sector, and a particular track, if you identify for all the platters, that is called the cylinder. Okay, track number one of sorry track number 5 of platter number 1, track number 5 of platter number 2, track number 5 of platter number 3. So all these forms a cylinder. Okay, then we studied what is transfer rate, what is positioning time. Positioning time means what? To get the particular track of a particular platter. Seek time means in that particular in that particular track, what is the sector we are okay, what is the sector we are going to reach. Okay, so always search start from, for example, innermost track or outermost track. Okay, always a first search will start from innermost track or outermost track. It depends upon the last positioning of your read write head. Okay, so if you want to search a particular sector number 5 of track number 5, first we have to go to the track. So arm assembly have to move from outermost track to innermost. So track number 1, 2, 3, 4, 5. Then the platter will start rotating. When it is rotating, it will find out the particular sector number. That is what we are referring as latency time. Okay. Then how it is functioning, nature of speed, and read rate. Of course, how it will not touch the platter like that we have studied. Okay, it will just floating just above the platter. So through magnetic material or magnetic effect only, data will be written on the platter. Head crash, if the read write head touches the platter, then crash may occur. Then we studied some of the types of memory, flash memory and corresponding types. So one important type is solid state disk. So difference between hard disk and the solid state disk. One is there is no moving parts in SSD, so we are considering it as reliable. There is no seek time and latency time, so we are considering it as faster, consumes less power, at the same time more cost and short lifespan. Then we studied magnetic tape. If you remember the memory hierarchy, what we have discussed in the first unit, the bottommost is magnetic tape. Okay, topmost is register. Magnetic tape is the largest storage device. Okay, so there is no any limitation. Okay, so once it is the largest storage device, of course, it will be the lowest speed. Accessing speed will be the lowest. Register accessing speed will be the highest. Very traditional. Then we, I think, started discussing about disk formatting. Okay, I told them formatting means making the disk to be ready to accept the data. Okay, making the compact disk or making the floppy disk to be ready to accept the data for storage as well as for writing as well as reading. Initially, it is considered as a blank slate. That is what we have given here. A new magnetic disk is a blank slate. It is just a platter of a magnetic recording material. I told one example as CD, and the hard disk is a combination of CD. So the hard disk initially considered as a blank slate only. Okay, it is just a blank slate. We cannot read or write anything on the particular disk. Okay, initially we cannot read or write anything on the hard disk. So how can we include reading and writing? Before a disk can store data, it must be divided into sectors that the disk controller can read and write. So in order to make the hard disk to accept reading and writing, it must be divided into sectors. Okay, if you want to divide it into sectors, already it must be divided into tracks. Okay, so dividing a particular hard disk into tracks and each tracks into sectors is referred as formatting. Okay, so one important thing you have to understand, you can store data only if the disk is formatted as sectors and tracks. Okay, formatting the disk for sectors and tracks is referred as low level formatting or physical formatting. Okay, so two more questions if they are asking what do you mean? Level formatting fills the disk with the special data structure for each sector. Already I told dividing the platter into various sectors is formatting. This formatting does one more thing. What thing? Assigning special data structure for each sector. Data structure means what? In what order I can store data on a particular sector. Okay, dividing the platter into sector is low level formatting. At the time of division, we are making or we are giving instruction at what form we can store the data on the particular sector. That is what we are referring as data structure. Last semester we have studied what are the different data structures available. So we have to follow any one data structure so that we can store the particular data on the particular sector. Okay. So what do you mean by the data structure? Data structure for a sector typically consists of a header, data area, and a trailer. Like our assigning a special data structure means the particular sector will be assigned one header, one data area, and one trailer. Okay, so platter is divided into sectors, that is low level formatting. Each sector is assigning a data structure. When we are assigning data structure, what we are doing? We are assigning a header, data part, and a trailer. So what does it mean? Each sector will have one header, one data area, and one trailer. Okay. Data area we will store data. That is obvious. What will be in header and a trailer? The header and the trailer contain information used by the disk controller such as sector number and an error correcting code. For example, in header, you can have sector number or track number 1 bar 2 means what? Track number 1, sector number 2. Like that, one identification about the sector will be available in header. One example is sector number. Okay, so what will be available in trailer? Error correcting code. Okay, I will just give one small definition about error correcting code. That is not our syllabus, but anyway, you should know about that. Okay, so data part is there, correct? Data part we will store the data. We will apply some processing on the data. Okay, for example, if you have like this, f of x equal to, I have one function, okay, f of x equal to x squared plus 5. Okay. If x value is 5, what does it mean? 5 squared plus 5. Okay. So 25 plus 5, 30. Okay. Okay. Are you able to understand? So now assume what data I am storing in that particular sector is 5. Okay. The function or the operation what I am doing is x squared plus 5. For f of x, I am storing or I am giving x squared plus 5. This others do not know about this. That means what? Third person or another person do not know about this function. Okay, they know only 30 is stored in error correcting code. That is at the trailer. Okay, so consider this as sector. In sector, we will have sector number as a header. Data part I am storing as 5 and trailer part I am storing as 30. And nobody knows how I got this number as 30. That I only know because I am doing some operation on the data I am having. Okay. After some time, I want to see the data. Okay. So I am performing this function with the data. If I get 30, then I can understand, okay, my data is not modified. or my data is not corrupted. Suppose if you get the answer as 35, what does it mean? The data you are stored in this particular data area is not 5. Okay, so the function is x squared plus 5. I should get only 30. If I get 35, or if I get 25, or if I get 100, then I can identify that it is not the data what is stored, it was modified, or it was interrupted or corrupted by third person. Okay, that is what we are referring as error correcting code. Okay, so a particular sector will have sector number as header, data part what data you are storing, and trailer part you are having error correcting code. So what is the use of error correcting code? To find out the data is correct or not, even after some days. Okay. So disk formatting, the OS still needs to record its own data structure on the disk. That will be done in 2 steps. So what is first step? Dividing the platter into tracks and the sectors. First step. Second step is loading data structure or assigning data structure for the particular sector. That is low level formatting or physical formatting. And the third step, partition the disk into one or more group of cylinders. I think in the last class, in the particular diagram of hard disk, I have shown what is a cylinder. Okay, so this is first platter, this is second platter, this is third platter. Like that, we are having so many platters. Okay, so here, this is for example track. This is track number 5. So for each platter, I am having track number 5. This track number 5 of all the platters is referred as cylinder. Okay, if you consider only track number 5 of all the platters, that is referred as cylinder. Okay, so partition the disk into one or more groups of cylinders, of course. Okay, so first partition is track, second partition is sector, third partition is cylinder. Okay, for instance, one partition can hold a copy of the operating system's executable code while other holds user files. Okay, in this one partition, if you remember, in main memory, what we will do always? Main memory always divided into two part, one for part operating system, remaining part for user program. Like that, in hard disk partition also, we used to always allocate one partition for storing operating system. Okay, underline the word copy of the operating system, because if you have it in main memory, if you switch off the computer, that will go off. Okay, but at the same time, you can execute the process only that is available in main memory. So what I will do? Load operating system from secondary storage to primary memory. That is referred as loading operating system. Okay, so main memory, from secondary memory to main memory, I have to load the operating system. Okay. So one partition we will use for operating system, remaining partitions for user files. Okay. Now, third step is logical formatting means creation of file system. Okay, first is dividing it into track, then dividing it into sectors, then assigning data structure, that is physical formatting, then assigning file system, that is referred as logical formatting. What do you mean by file system? File system, you know, what is the file name, what is the file access method, file attributes, so many things are associated with the file. Okay, file creation date, file modification date, file size, file type, all these things are required for a particular file. What type of file system you are going to use for the particular hard disk or for the corresponding operating system. Okay, I think you are able to understand. So disk partition, first is track, second one is sector, third one is physical formatting, that is assigning data structure, fourth one is logical formatting, that is assigning file system. Okay, this is what we are referring as disk formatting. Disk formatting is partition as a large sequential array of logical blocks without any file system data structure. The array is sometimes called as a raw disk. This is what I told in the beginning. Blank slate, like that we used to tell, no, blank slate. That is raw disk or fresh disk. When it will be usable disk? After logical formatting and physical formatting. Now the disk is ready for storing data and reading data. Okay. Next topic is boot block. I think already we talked about this word called booting. Booting means what? Loading operating system into main memory. Okay, I told after switching on the system, it will take a few minutes. After few minutes only, you will get the Windows screen. During that few minutes or few seconds, the process, what we are referring as booting. Booting, what do you mean by booting? Loading operating system onto main memory. Okay, what is the purpose of loading OS onto main memory? So that it will check every components of the computer system is functioning properly or not. Okay, it will check all the components or elements of the computer system functioning correctly or not. That is what we are referring as boot. Okay, what do you mean by block? Block means a partition of a hard disk or a secondary storage device. Okay, a partition in a secondary storage device is referred as block. In our concepts, what we have studied already, it is a sector. Already you know what is a sector. So consider sector as a block. That's all. Normally, the block size will be 512 bytes. Okay, 512 bytes. That is 512 bytes. Normally, a sector size or block size will be 512 bytes. Okay. So, first concept is bootstrap program. What do you mean by bootstrap program? Initial program to run. As I told, once you switch on the system, the first program to be running is bootstrap program. Okay, initializes all aspects of the system from CPU registers to device controller. I told it will check all the elements or components of the computer system, not operating system. Okay, it will check all the elements or components of the computer system, input, output, and the CPU. Everything it will check and the contents of the main memory and then starts the operating system. Okay, to do its job, what has to be done? The bootstrap program finds the operating system kernel on the disk. Okay, in order to make the system to be ready for functioning, first this program will check whether operating system is loaded or not. Okay, then if it is found, load that operating system into main memory. Okay, first it should check whether OS is available in the secondary storage or not. If it is available, that OS must be loaded into the main memory and jumps to an initial address and begin the operating system execution. Okay, jumps to the initial address means what? First address of the operating system. Okay, so what is happening during booting? I told in only one line. Okay, loading operating system from secondary storage to main memory. That's all. Okay, for doing this, we are having one program. That program is referred as Bootstrap program, and that is the program what will be executed or what will be running as a first program once you switch on the system. Okay, so when you switch on the system, automatically this program will start running. When this program is running, what is the outcome of this program execution? Loads the operating system from secondary storage to main memory. Okay, in order to store this program, Bootstrap program, we have one block. That block is referred as boot block. Okay, upon now you know what is boot block, what is Bootstrap program, what is the function of Bootstrap program. Okay, last line you see very important. Bootstrap is stored in read only memory. Excuse. Bootstrap is stored in read only memory. I think you know about all these key terms: read only, RAM, PROM, EPROM, all those things you would have discussed in the first semester. I'm not going into that detail. Read only memory means what? You cannot make any modification. Why it is written there? Because modification, Normally in operating system, modification is not advisable because that is a very sensitive program, correct? It is not like your program, like you can modify then and there, not like that. It is a very sensitive program. So normally that is not allowed. At the same time, if a resource person or if a well equipped person in the operating system wants to modify, then option must be given. Okay, so bootstrap program is normally stored in read only memory, which is permanent, which is available in the registers, or which we cannot modify. Okay. So what is the problem of having that bootstrap program in read only memory? We cannot do any changes, of course. That is one advantage. Okay, changes should not be allowed. That is one advantage. At the same time, changes are inevitable. Okay, normally you may want to do any changes in any sort of program. Okay, if you want to change the settings, if you want to change the input output devices, of course it have to be changed. If it is in read on memory, what we have to do? We have to write one new program in another chip, and that must be loaded into the read only memory. So that, what does it mean? That ROM must be changed. You cannot go and modify and save. That must be removed, and the new ROM have to be stored with the new operating system. Okay, the new bootstrap program. Okay. So in order to avoid this, every time if you want to change, then whenever you want to change, if you're moving and replacing, it will become costly. So that only what we are doing, we are storing that bootstrap program in one block called boot block that is available in secondary storage. Now it is not ROM. It will not be in ROM. It will be in hard disk. Okay, hope you understand. Okay, now you know what is bootstrap program. Bootstrap program normally will be available in read-only memory. If we are having it in read-only memory, modifications cannot be done. So instead of storing it in read-only memory, I am storing it in one block of the hard disk. Okay, sector of the hard disk. So now, as far as hard disk is considered, you can change whenever you require that. Okay, you can change it whenever you require. Okay. A disk that has boot partition is called boot disk or system disk. Okay. Three important terms we have studied. One is boot block. So in boot block, what we are going to store? Bootstrap program. Normally, bootstrap program will be available in read-only memory. In that, we are having some issue. So we are storing it in boot block. That boot block will be available in our hard disk or disk. Simply saying this secondary storage. Okay, that partition is referred as boot disk. Okay, if your disk is having boot block, then that is referred as boot disk or system disk. Okay. Okay, so far we have discussed about boot block. Now we are talking about another important concept called the bad block. Okay, bad block, some fault. So what does it mean? Any product is subject to fault. Like that, your hard disk also subject to have some fault. Okay, all hard disks are not always 100% perfect. It may have some fault in itself. Okay, so disks is always subject to have some fault, or in other words, prone to failures. Okay, if the failure is complete, okay, what we have to do? Replace a disk and copy old to new using some recovery techniques. Okay, uh, that you know. I think if you have some problem with the hard disk, what you will do? Okay, if you have any problem, suppose if your system is not functioning, you want to reload your operating system means what? Normally, we will copy all the contents from one disk to another disk. Okay, from one secondary storage to another storage. So replace the disk and copy. So you have to buy a new disk, and that in that new disk you have to copy all the old files. Okay, to the new disk using some recovery techniques. Okay, some disk come from factory with the bad blocks. Okay, so if your hard disk is functioning properly, and at one stage if it is not working, you are buying a new hard disk, and storing all the old files to this new hard disk and start working. This is one method. Another method means sometimes hard disk will come with false built in inside. Okay, that is when you are buying a hard disk itself, it is subject to have some fault. Okay, normally the fault in that particular disk is considered as bad blocks. Okay, you know what is a block? Block nana sector. When you are doing logical formatting and the physical formatting, some sectors may not functioning properly. That means if you store data in that particular sector, it may not be stored properly, or it may not, it may stored as a wrong data. You store 10, that will show 15. Okay, that means what? That particular sector is not functioning properly. That is referred as bad sector or bad block. Okay, bad sector or bad block. How to solve this problem? Okay, one solution is sector sparing or sector forwarding. That means what? Spare. Okay, what do you mean by spare? Spare parts, like that we used to tell. Okay, spare means what? Extra copy, like stepney we are having in a car. Okay, so what does it mean? Whenever a fault occurs with one tire, we will replace it with particular tire. Okay, it doesn't mean one hard disk for another hard disk. Okay, one block for another block. Okay, suppose if you have one bad block, when you are storing the data, you find the data is not storing properly, then you are defining that as a bad block. That means what? Operating system will mark that particular block as a bad block. Next time when you are going and entering, for example, block number 10 is bad. Okay, block number 10 is bad. So operating system finds that it is bad block, and for this bad block 10, operating system uses a spare block with the number 20. This is spare block. So whatever you are writing on 10, that will be forwarded to 20. That is what we are referring as sector forward. Okay, so whatever data you are writing at bad block 10, because you don't know whether it is bad block or good block. User will not know. Only operating system knows. Okay, by doing some process. So operating system finds that particular sector as a bad sector. Now our OS itself is will assign a spare sector or spare block. So from that time onwards, whatever data you are storing at 10, that will be forwarded to 20, and OS will not allow you to write anything on 20 directly, because that will be considered as a spare block. Once it is marked as a spare block, you cannot write any data, because OS going to write. OS will identify that particular sector as a spare sector, so it will not allow anything to write that. Okay, that is one methodology, sector sparing or sector forwarding. Another one is sector slipping. If you remember, inserting an element in an array, what will happen? So these are all sectors. Okay, these are all sectors, or these are all considered as blocks. Suppose this block is fault. Okay, so here I am having some data 1, 2, 3. Here I am having 4 actually, 5, 6, 7, 8, and I'm continuing here. So up to this I'm having data. These are blocks are free. Okay, now identify some error, or this is considered as a bad block or bad sector. Now what will happen? 9 will move here, 8 will be moved here, 7 will be moved here, and 4 will be moved here. That is one step further, moving each and every sector one step further, so that to store the data. Okay, so what is the difference between sector sparing and sector slipping? Sector sparing means what? At one place of the disk, we will assign one sector as a spare sector, and whatever data you are writing in the bad block, that will be forwarded to the particular block. Okay, it may be available in any one location of the disk. That is sector sparing. Sector slipping means what? Next, it will identify next continuous free space, and all the data up to that free space will move one step forward. Okay, exactly as same as inserting an element in an array. Okay, inserting an element in the array, what will happen? 10th data will be moved to 11th position, 9th data to 10th position, 8th data to 9th position. Like that, we will move one by one. Finally, you will have one free space. In that space, you will insert the data. Like that, we are here inserting the particular sector or block.